Thanks for coming. I know it's near the end of the day, and you guys are probably pretty tired. Today, I'd like to talk to you about a new project that we've been working on called Skipper. And it helps you automate the deployments of apps to multiple platforms. A little bit about me. I've been working on Spring projects for quite a while in reverse order. Did Spring Cloud Dataflow together with Mark Fisher for many years, and before that, Spring XD. And the cute little project actually gives, in some sense, the most joy is Spring Shell, because it can build in about under 30 seconds. And before that, Spring Data, and it's a family of projects that are now led by Oliver Gehrke. Port of the Spring Framework to .NET, and then JMS Template was my first encounter with Jürgen and folks, so going back quite a while. And today I'd like to introduce a new project called Spring Cloud Skipper. So the history I just mentioned led me to create, and other members of our team who are probably here, Alaya and Yana. You're there you are. Everyone can turn around. Give them a round of applause. The problem we needed to solve in Dataflow was we have apps deployed on Cloud Foundry and Kubernetes and elsewhere, which look like this. There are boot apps connected through messaging middleware. And it's very common that you'll use one of our prepackaged applications to consume data from an HTTP endpoint that gets published to a message bus. And then you do some custom business logic. And then let's say after doing that, you want to write this streaming of events into JDBC. So what happens when you want to upgrade your business logic, change the Java code, not just change properties, which might be handled through something like a config server? So you're going basically from some V1 to V2. And the problem we had in Dataflow was we couldn't do this just like I did magically here on the slide. We had to tear down the entire 3 applications and then stand them up. Or you went down to the command line of either Kubernetes or Cloud Foundry and started to do your own commands, which work, but then the sort of orchestrating process Dataflow didn't know about it. So it's kind of like going behind its back, and it was not very, very nice. So we took a look around of what is out there, right? How do people handle updating apps? It's not like it's the first person to ask this question. And I say, the most common Hello World example is someone just kind of puts a CF push statement, or the Kubernetes equivalent, at the end of a build process in pick your favorite CI platform. That's like the Hello World getting started. Usually, things get more complex than that, right? People will not just want to push it out willy-nilly. They'll want to put it through some testing, make sure it's healthy under various conditions. Maybe in your enterprise, you have to have someone manually sign off after looking at some sort of monitoring that it's OK, and so there's a gatekeeper process. So it's kind of a simple thing. There's another project out there from Netflix called Spinnaker, and it's very cool. It really has a lot of great features, but it's very big, meaning it's like 7 or 8 servers. So there are a lot of cool ideas in there, but if I told the Dataflow users to upgrade one app, you need to install 7, they'd kick me out the door. So looking around in the Kubernetes space, there's a project called Helm, which is officially part of Kubernetes. And this one kind of really had a nice look and feel. It really started life as a package manager for Kubernetes, meaning the equivalent of apt-get or brew. And because Kubernetes itself has sort of rolling updates features, it can kind of leverage that functionality. And there are some hooks to do more, but it's very much focused on searching and installing and then doing like upgrades to the command line. There's another project also in the Kubernetes space from Weaveworks. And I think they also have a very interesting approach. I'll show you some of their thinking, which I agree with, which led to Skipper. And of course, you have your traditional package managers. So I looked at the Unix ones, Node, Maven. There's all sorts of different things. So I just tried to get a refresher. And this article, it's a quick read, but I think it's pretty good. It shows the evolution, really, of doing continuous deployment, starting simple, and what are the problems along the way. So I'm going to walk through kind of the slides from that article, because they're pretty good. They're not Cloud Foundry-centric. They're Kubernetes-centric, but the basic idea still comes across. So they go through V1, V2, and V3 type nomenclature. So first, they started very simple. You check in your code. It triggers a build. And then in the CI system itself, through some task that you would have, it would, well, the build would publish to the Docker registry. And then you'd have kubectl push, the equivalent of updating a service. And the problem with this, at least in their view, interesting for Kubernetes, is that in order to roll back, to go to a previous version, you have to revert the last commit, let's say, right? And then you have to go through the process of rebuilding an image that basically you already had before, right? If this is your universe, that's the only way it works, right? And so they felt it was really inefficient to have to rebuild and stage a whole new Docker image for something you just built previously. That's sort of a downside of this one. So the second sort of improvement they made was the CI system now would write the YAML files that would go out to be pushed into Kubernetes. And then if you wanted to go back to a previous version, you had the whole list, basically, of everything that was pushed to Kubernetes. So it was declarative in nature. You had a document, it was version controlled, and you can just check out the previous version and then push that up to Kubernetes, and off it would go. And when you start implementing this, right, your one-liner starts to be doing a lot more, right? All of a sudden, you're committing stuff, and it's just getting a bit heavy, right? It's not a simple thing to stick into. And sort of unnatural to go back to a CI system build and figure out how to roll it back to a previous version. So the idea was that you delegate to a separate server. They call it the release manager, that in the case here of Docker registries have a webhook, and they say, I got a new image, and that's the mechanism of handoff. So the CI system really doesn't even know about the fact that something is pushing it to production, let's say. It just pushes it to Docker registry, and you can point this release manager to pay attention to as many endpoints as you like. And this, I think, is the essence of a nice architecture for doing sophisticated things. You basically have a nice separation of concerns. The CI system does all the testing you want, checking for, obviously, integration tests, checking for new versions, working with older versions, code coverage, you name it. But then when you finally need time to deploy, maybe it's a long-lived process, like a manual process. That has to live outside the build system in CI. And this little scroll wheel for policy means you can start to institute policies of basically who can deploy what where that are totally independent of your CI username, right? Because usually the CI build runs under some username. So a lot of flexibility in this approach, and if you go back and read the article, you'll find it a good read. So the takeaways from that and sort of just generally perusing around was don't have the CI system do too much. Delegate to another system once you get beyond a certain level of complexity, which I think happens in most enterprises. Rolling back should be easy. You shouldn't have to rebuild everything if you already had an image. And this idea of having a single source of truth, basically these YAML files, in the case of Kubernetes, and we'll see also in the case of Skipper, basically represent what was pushed to the platform. And since they're documents, you can template them, which means you could easily substitute values so that you don't have to edit the bizarre location in a YAML file where the one particular property you want to change is. So it really simplifies that whole configuration. And then metadata is used to search for what apps are available. So you can say what's out there. And then what's also interesting, this is something Spinnaker does, is you can have metadata associated with an instance. So then if you want to know everything in QA, you could query, show me all the apps there in QA. and it keeps track of that for you. So Skipper was meant to sort of fulfill that goal and those features. So number one, it's a tool to search for what's out there, much like when you have apt-get or brew. You can kind of first browse what's out there, and then manage their lifecycle on multiple cloud platforms. So you can use it just alone, or I'll show later, you can use it inside of a CI platform. And there's a link to the homepage and the release. Since everything in Kubernetes land is based on nautical themes, I picked one of my favorite characters from my childhood, Skipper from Gilligan's Island, and it's good because he's sort of in charge of the boat. So now he's going to be in charge of your boot apps. So I'm going to dive into using it. So here, actually, let me start completely from scratch. And maybe make the font a bit bigger. Oops. Yeah. Even bigger still. So there's a server where all the magic happens. And there's a shell. Which, by the way, I think is the same font as this when it starts up. Oh, no banner in this one. OK. So first, I want to show you about platforms. Yeah?
Can you change
The
the font?
font?
Bigger.
Oh, bigger. That better? Yeah? One more. Let me make it wider, because there are tables. There we go. So first, you can give a list of what platforms Skipper knows about. Basically, you can configure it with an arbitrary number of Kubernetes namespaces or Cloud Foundry org and space locations. And here, since I'm running it on my laptop, there's a default one, and it's to deploy processes locally. So that gives you a list, and whenever you need to deploy to a certain place, you pass in this name. There's the idea of package repositories. This is where software lives. So these are the two locations. One is sitting at this address, and the other one is basically an embedded database. So you can upload packages to Skipper if it's backed by its own database. Otherwise, they're hosted on a read-only sort of static type website. So if you pop open to this one, this is that website. And if I open up its index file, let's see if I can. This is essentially a bunch of metadata about the packages that are there. Its name is helloworld, who maintains it, where it lives, tags, and so on for search. Yeah?
Is it possible to read from a Maven repository? Or is that a possibility?
Yeah, I'll show you the link to Maven and Docker in just a second. So the answer is yes, and I'll show you how. So that's the index file. And if you go to this app here, so basically, you might not be able to zoom this part. There's a simple directory structure, static files. So the hello world package lives under the directory hello world, and then there's a zip file there. And the zip file contains a bunch of YAML files that I'll show you next, and that's where the link to the Maven repository is. So here's hello world. Here's its own package file, which is what's used to create that large index, just kind of squash up all the documents together. And here's sort of the meat of it, and it probably looks a little weird at first, but I'll walk through it. So you have sort of this Kubernetes-inspired YAML document. So there's metadata that later we could use for searching for apps of this type. And here's where the link is. So this is a sort of URL for Maven with the group and artifact ID. And then what's here is important is I have a version, and it's a property. This is using Mustache for templating. And so this property, you can specify a default value in a file called YAML, values.yaml, and that will be the default value here. However, you can override this later when you're doing installs or updates, and that's how you can migrate between versions. And then because we're dealing with Spring Boot apps, so this only knows about Spring Boot apps, because underneath we use libraries that we use in Dataflow called app deployer libraries. These know how to deploy Spring Boot apps to multiple platforms. So you can pass in any set of boot properties, so like server.port, a common one, right? And then deployment properties are things specific to the deployer library, like the memory size of the instance you want to run on Cloud Foundry. And so these are empty, and you would have to specify them when using it to have some values in there. So that's all that this is. And for Docker, it looks the same pretty much. There's just the syntax for resolving it from Docker. So I'll pop back to here. So let's see. Oh, yeah, so search, right? There's the thing. Let me make sure everything is clean there. Yep, that's JPS running in the background. So I'm going to install a package, and you have to give it a unique release name. So I'll do hello world local, package name, hello world. Oh, I didn't show you the hello world app. It's really super simple. Here's the controller. Basically, there's a YAML file that gets substituted with the name and version during the Maven build process. The controller just returns those versions, and there's a greeting property. Default is hello world. So that's it, 2 endpoints. That's what it describes up here as well. So then I'll pick a version. So version 100 says hello in English. 101 is a code change, even though you could pass in a property to the same effect. The default is saying hello in Portuguese. So 1.0.0. And I'm going to pass in some properties. So this follows the application. Because it's local, I don't want the next one to crash or conflict with port conflicts since it's on the local server. So this is going to release this guy, right? And so if I go here, I'll make it bigger everywhere. There's the greeting, and it's version 1, right? You can all see that. So now I can, let's do an, let's see, status, another command. Release name, hello world local. So they're all deployed. So now I can do an upgrade. I have to give it the release name I'm interested in, local. Package name, hello world, properties. And now I'll give another port so it doesn't conflict. And then I'm going to, version. Oh, thank you. And so these have already been published to a repository that's hosted at the repo Spring libraries. So just do that. So now it goes to version 2. So you'll see version 2 pop up here, hopefully. I mean version 101, unless I made a typo, which it looks like I did. No. Differences detected. Cannot get status. Right? That sucks.
Previous example had -- version.
Yeah, I did that on purpose. But, that's weird, isn't it? Oops, sorry. That is really unusual. Okay, let's install this again. Oops. Let's do this. Sorry, guys. Of course, no matter how many times I did it beforehand, it screws up here. Let's see, do this one. Oh, I think I didn't do dot release. Oops, that was it. All right, so let's do this install. All right, so that's running, and that's that. And now, yeah, I think I forgot the dot release, sorry. So now, there. So now it's waiting for 1 to give a good health indication, and then it kills 2. So now I can look at the history of this, or I could actually maybe do the curl. So it's in Portuguese, and it's the next release. And if I do list, that's what's running. Unfortunately, need to shrink the font just for a minute. All right, so hello world local, when it was installed, what is the package version there? So let's also do history, release name, hello world local. So that's the history of things. And now I can roll back, release name, hello world local, release version 1. So now this is going to drop back to 1.00. And now if I do this, you see it's version 1.0 at that endpoint. So now I'll just see how I'm doing on time. So only a half hour, yeah. I'll just show quickly on Cloud Foundry and then get back to the slides. So platform list. I look here at my, oops, that's the wrong space. Yep, that's the right space. So this is the space I call QA. So yeah, install, same thing. Release name, hello world, CFQA, platform name, CFQA, package name, hello world, package version. And here I'm going to pass it a file with some YAML in it, since it's a lot better to do that than, and so I'll show you what's in that file. So here I passed in, just for fun, some application properties. So to make all the boot endpoints not sensitive, I gave it a route specifically because I won't have time to show it, but if you push this to another org space on PWS, you have to make sure the route is unique and they would clash. And just to show the memory setting. So you can have those sitting in a YAML file and not have to squeeze it all on in this kind of condensed property style. So this is going to do the same thing, except on Cloud Foundry. So here's the guy. There's the thing, the logs, tail that. So this takes just a minute. If I go over here, once it's done, I gotta prepare the, it's not ready. Oh, it did come up. All right, so version 1.0. Now do the same thing, upgrade. Release name, hello world. Package name. I'll do this time. Nope. And so this guy, I just set the greeting. I override it to yo, and change the memory to 2, right? Even though I'm using a different package. So it shows sort of different combinations of doing things. So now, actually, it might be easier to do it this way. So you see V2 is coming up, V1 is still hanging around. And if you go back to the space and look at V2 and the logs, eventually this guy is going to come up. I got 3 minutes left, so this will be almost the last demo. So that's getting close. So now go back here. And so now it's updated to 1. So just the same as local, and I have Kubernetes running here as well, and that would just not be enough time to do that now. So I'll show one last thing. Oh yes, you can look at the manifest, for example, release name, hello world, CFQA, right? And so this is the finalized YAML. You see it has this, it has the route, it has the greeting. So that's the sort of single source of truth of what's been pushed out there. And you can ask for different revisions of it, but I won't get there. So list, so let's kill the local one. Hello world local, and I will I need to prep this. So I let you know about something called Hello World Jenkins. And then the reason for that, so now if you look at JPS, this is the one that was released from doing that command. And I'll shoot on over to Jenkins here. So in the Jenkins file, I think I have it here. No, too many windows. I forget which one I put it in. Oh, that looks good. Right, there's stages in the build. So check it out. And then here's just a simple way to do this inside the build. Create a version based on the date, then install. And here I call Skipper to upgrade, passing in that version that was just built. So you can do it interactively, or you can do it just passing the commands as if it's executable. So if I pop back to that, here I say build now, and it should start to build. So there it's called the thing, it's finished. And if you go back to JPS, you see it's in the process of pushing the latest one from your CI system out to run. So let me just go back to the slides. That's my timer. So these are the main concepts. I'll wrap it up really quick. Packages are the description of what can be deployed. Platforms are where they can be deployed. Package repositories are basically websites that host what packages exist, and you can point to them. Releases, you saw I was typing release name over and over again. That's like the key that you associate with a package that has been deployed, so it references a real running instance. And the manifest is that finalized YAML. So if you want to know what was deployed, you look at that, and that should basically tell you everything there is to need to know. So this is sort of just a little bit of how it works. I mean, there was a client, a shell, and then all these different deployer implementations live there. And we keep the YAML and other stuff stored in the database, the repositories. And the zip files, too, are stored there. I showed the Jenkins integration. So this is our sort of short roadmap of what we plan to do. Right now, version 1 just understands this YAML, which we made up, frankly, right, to describe Spring Boot applications. The way in which we do the upgrade now is kind of serialized in Java code, but there's a real hidden gem of a project called Spring State Machine, where we can really formally control all the states to do a blue-green deployment, or do a rolling blue-green deployment, and make sure that every step along the way, conditions are met, or notifications are done, or you can add Spring security annotations to make sure they're proper configuration for that. That's what I mean by the health checks, different ways. Check the HTTP endpoint, or check some sort of backend that was collecting metrics that has more detailed health information. And then beyond that, this is really, maybe this list should have been reversed. It should be, I'm very interested to get feedback from people who are interested to try this approach or stick it into their existing CI pipelines. But some of the obvious ones that come up are, more update strategies, roles, who can deploy what where. And then since the engine, which is inside Skipper, it's really, at heart, a giant templating engine, right, with YAML. It doesn't have to be the YAML that we made. It could be a CF manifest, for example. And so that would open the door to doing things beyond Spring Boot apps on Cloud Foundry and make it sort of more polyglot. It comes with additional things, right? You have to then also have YAML, which doesn't exist anywhere, which says what services to create, right? Which they might not have been created already. And then you can go behind Skipper's back, in a way, right? You can still go CF push something, and then you have a conflict. And we have some ideas how to handle that. But those are some of the features we're thinking about. So that's the website, and we have a Giter channel. So I encourage you to check it out. It's listed on the project site. And ask questions. We're there, the development team, looking to respond to your questions in real time. And thank you for hanging out for an extra few minutes.